Welcome back. Now let us write the convert function that converts the infix string to the corresponding postfix string exactly according to the algorithm that we did earlier. The convert function receives two parameters, both are character arrays. The first one is the infix that contains the infix expression, which is the input. And the second one is the postfix that contains nothing at the beginning. That means when the function convert is called, the postfix is only the base address to the array postfix. And when we'll go through the conversion routine, ultimately this postfix array is going to contain the postfix string. So here you can see that in the main function, we have two arrays. One is the infix, that is a character array, and the second one is the postfix, again a character array. And we are scanning the infix expression here using the scanf from the keyboard. Then we are calling the convert function. The first parameter is the base address to this infix array that contains the infix expression. And the second is the base address to the postfix array, which contains nothing when you call the function. But when the function is over, this postfix array is going to contain the postfix expression. So here we are printing the postfix array to get the postfix expression there in the console. So let's now develop this convert routine. Of course, we need a stack for this purpose. So I'm declaring an operator stack to keep the operators and initializing the stack top to -1. We need two integer variables to access the elements of both the arrays. So I'm declaring I and j for this purpose. I will be used for accessing the elements of infix array and j will be used for accessing the elements of postfix array. Now we need to initialize I with 0 because we want to start from the very beginning of both of the strings. Okay, and j is initialized as well with 0. Now I'm writing a while loop to traverse through the infix string until we reach the end of the string. So infix I not equals null. Okay, that means this while loop is going to iterate as long as we are not getting the null character. Null is the terminating character. We know that any character string is having a null character at the end of the string. So if we get the null character, we'll terminate. At the end of each iteration, we need to increment I by 1. So I'm doing this I++. Okay, now we need to get the next element from the infix string, and that is our token. So character token equals infix I. So we get the token there, and now we need to check whether this token is an operand or operator. So I'm writing an if statement. If token is greater than equals 0 and token is less than equals 9. That means if the token is an operand. Let me write a comment there that will make more sense. Okay. If the token is an operand, then what I need to do is to place this token at the end of the postfix string. So postfix j, we are using j for accessing the postfix elements, equals this token. Now this token will be placed at the jth element of the postfix string, which is the current element. Now we need to forward this j to the next elements. So I'm using the post increment operator with j that will increase the value of j after using the current value. That means if the j is right now at 0th element, token will be assigned to the 0th element, then the j will be incremented by 1. So in the next time, we'll get the next element by using j in the postfix string. Okay, that is how we handled the case when the token is an operand. Now, if the token is an operator, then we need to check if the stack is empty or not. If the stack is not empty, then we need to compare the precedence of the stack top operator with this token. If the stack top is having the higher precedence, then we'll be popping the stack and we'll be appending that top operator with the postfix string. Otherwise, if the token is having the higher precedence, then we'll be actually pushing this token into the stack, provided this token is not a closing parenthesis. If the token is a closing parenthesis, then the stack top contains the corresponding opening parenthesis. And we have always considered that this infix string is a valid infix string. So if the token is a closing parenthesis, then obviously the stack top contains the corresponding opening parenthesis, and we need to discard that. So if the token is a closing parenthesis, then the precedence function will return false, and we'll be actually popping the stack and we'll be discarding both of these opening and closing parentheses. And otherwise, if the token is having the higher precedence for any other operator, we'll be actually pushing that token into the stack. So let's move on. So if the token is an operator, that means there could be these different cases. As you can see, these are the different operators that the token may have: plus, minus, times, division, dollar, opening parenthesis, and closing parenthesis. So if either of these are there in the token, then it's an operator. So let me write the comment there. If the token is an operator, then what we need to do is to check whether the stack is empty or not. If the stack is not empty, then we need to compare the precedence of the stack top with that of the token. And if the stack top is having the higher precedence, we need to pop it out and we need to append it with the postfix string. Otherwise, if the stack is empty or the precedence of the token is higher than that of the stack top, then we need to push the token into the stack. And we need to continue this checking unless and until we have the stack empty or the precedence of the token is higher. So I need to write a while loop there. If the stack is not empty, stack.top not equals -1, and the precedence of the stack top. Now how you could get the stack top? It's simple, stack.item, that's the item array within the stack. And to get the top element, we just can write stack.top there. Now this is going to return me the top element, and we are not decrementing the top, we are just accessing the top element. Okay, and the second parameter is of course token. Now this precedence function is going to compare the stack top with the token. Now if this precedence function returns true and the stack is not empty and this precedence returns true, in that case what we need to do, we are inside the while loop and we need to pop the stack and we need to append that operator with the postfix string. So here we go, top operator equals pop the stack, and we are passing the stack address there. Great, we get the top operator from the stack and we need to append this top underscore OPR with the postfix string. So postfix, the current place is j, and we need to increment j by 1 after using the current index. Again, this top operator is going to be assigned at the jth index of the postfix array, and then after this assignment, the j will be incremented to the next element. Okay, so when the while loop fails, that means if the stack is empty or if the token is having the higher precedence than the stack top, then this while loop fails and we come out of the while loop. And what we need to do is to check whether this token is a closing parenthesis or not. If the token is a closing parenthesis, then we need to just discard that by popping it out. Otherwise, we need to push the operator into the stack. So I just need to check if the token is a closing parenthesis. That means the stack top is obviously the opening parenthesis. Okay, so we need to discard both of them. So in this case, what we need to do is to call the pop operation and we need to discard that opening parenthesis. Okay. Now you can see that we are just not assigning the return value of this pop operation anywhere. Actually, we are just getting that top element, that is the opening parenthesis, and discarding that. Otherwise, what we need to do is to push this into the stack. So OPR underscore push, passing the address of the stack as the first parameter, and the second one is the token. So this token is going to be pushed into the stack if that is anything else other than the closing bracket. I mean the closing parenthesis. Okay, so we are done. Now, for anything else we encounter other than these operators or operand, then we just printing a message there and just terminating the process, because whatever the character that this program encounters is not a valid one. So let me just give a message there, invalid symbol encountered, invalid symbol, and we can print that symbol as well, %c encountered, and let me just print that is there in the token, and I'm terminating the program by calling the exit operation. So that will be terminated. The program will be terminated in that case if it encounters with some invalid symbol, anything other than the operator or operands. Okay, so now when we come out of this outer while loop, this is the end of the while, outer while, Now when you come out of the while loop, we'll be coming out of this while loop when the end of the infix string is encountered. As you can see that we have this while loop condition here, infix I not equals null. That means when the ith element is the null, that means we come to the end of the infix string. So now what we need to do is to pop out the stack to get all the operators there in the stack, and we need to append them with the postfix string. So we need to iterate using a while loop as long as the stack is not empty. So stack dot top not equals -1. We need to pop the stack, and whatever the operators are there in the stack, we need to append them with the postfix string. So character top OPR, calling the pop operation again, passing the stack address. So it is going to pop out the operator in the stack top, and we are going to append this with the postfix string. So postfix j++ equals top operator. Now, one more thing that is left there, we need to just add a null character at the end of the postfix string to mark the end of the string. So postfix j equals null, and that makes it a null terminated string, and we can use it in a standard way. So that's it. We are done. Now it's testing time. Let me just test this. I'll try to compile it and I'll try to execute it. Okay, let's go ahead. Let me now compile and execute this program. GCC into post.c. Okay, it gets compiled. Now I'm running this. It is asking for the infix. Let me give a simple one for the very first time. So 8 plus 9 is printed as 8, 9 plus. You can see that it's working fine. Let me test with some other input values. Okay, here we go. I'm giving 8 times opening parenthesis 9 minus 2 to the power 7. Now you can see that it has been converted to the equivalent postfix, and that is correct. Okay, you can just test the program with different test cases. You can provide infix strings according to your wish and can check whether the program is going fine or not. Okay, that's it. That was a very lengthy session. I understand that. We started with the Polish notations and the reverse Polish notations, and we understood how they help us to write programs in order to find the value for an expression. And we saw how the stack works in these programs. Now, if you have completed this journey along with me, then I'll say that you are now master in stack. You have understood the stack clearly. So I will recommend you to just write all these programs by yourself and try to execute them and have fun. Now in the next section, we'll be starting the queue data structure. That's the other important data structure that I will be discussing with you in this tutorial, in this course. So let's go ahead and understand queue now. Should you face any trouble understanding all these conceptions about stack, about these Polish and reverse Polish notations, then feel free to ask a question in the forum. I'll be attending your questions always. No worries. Thank you very much and happy learning.